Make sure I'm on the, okay. All right, guys, welcome to the drafting training. This week we're going to be going over Revit sloped walls. So again, most of you guys probably know me. I'm Gabriel Avila, so I'll be going over how to create those sloped walls in Revit. So I'll be doing a little bit of PowerPoint, and then I'll be moving to Revit so we can actually create something. All right, so let's move on to the next slide. Come on, there we go. So key takeaways for today, just so you guys know, sloped walls are not created the same way as flat walls, which we'll go over in a minute. Why? Sloping into the building versus out of the building require different families. Big point there, just because the way Revit thinks the wall is being created, and then parameters must be set correctly in order for it to be taken off. So there are some parameters that I'll show you guys. Some that are built in already, some that you have to check based on the way the wall is sloping. Okay. First of all, we need to understand how curtain walls are created. So with regular curtain walls, what we're doing, we're using the wall feature in Revit. So what we're doing is creating a wall and using that as our rough opening. So you can see here I have like a strip window. I have a rough opening that covers the whole container of the units, and then I nest a wall in that one, and those will be my units. So for example, you can see on this, I don't know if you can see my mouse, but you can see that it's highlighted a unit that's within the vertical grid lines that we created. So that's actually a nested wall inside of a giant rough opening that we can put like caulk joints and our seal track on. So that's the way we create curtain walls in operations. And like it says, emollients and glass are applied to the unit, and then they're placed accordingly. Okay, so that's how we're created. Just a little background of how we're creating curtain walls, because when you create slope walls, we're actually using what's called a roof by footprint feature in Revit, because right now, currently in Revit versions 2017 through Revit 2020, they don't allow for a regular wall to be sloped. So we kind of worked around where we used the roof by footprint to actually create these sloped walls. I don't know if you guys have heard, but Revit 2021, they actually have a feature where it's a wall that's actually being sloped. So excited for that. Hopefully we get some projects in there where we have sloped walls, we can use that feature. But for now, we're using the roof by footprint. And like I said, slope walls are created as standalone units. So you can see here, I created a unit. They're actually placed next to each other. So unlike the curtain walls where you have a rough opening that contains these units, with slope walls, they're individual units kind of placed next to each other instead of like in a container. And stacked onto each other. Because we don't have the ability to slope regular walls like I mentioned, or nest roofs in roofs, which is not possible, if that makes sense. And then, like I mentioned, slope in versus slope out walls, they behave differently. You'll notice on this, in this properties, there's this sloped exterior faces down. That's for the takeoff program to be able to pick up which way the wall is sloping, whether it's in the building or out of the building. So depending on that, you have to check that. By default, it's not checked. So depending on which way your wall is facing, you have to check that, because that'll allow the takeoff program to identify it correctly and make sure it's translated into the takeoffs and the fabs. And like I said previously, the mullions and glass must be flipped because of the way the wall, Revit thinks the wall is being created. All right, so that's pretty much it for the PowerPoint. I'm going to go dive into a full demo on creating these in Revit. I'm going to switch over to Revit and show you guys. So like I mentioned before, we'll go ahead and take a look at our elevation real quick. So this is a curtain wall. Oops, sorry. This is a curtain wall. You can see this is the rough opening. So this contains all the units inside of it. So say for whatever reason I stretch this unit gets bigger. So that's with curtain walls. And then you can see if I tab in here, click on this, this is my unit, which is called W7511-001. So that's for curtain walls. And then with slope walls, I mean, just made one, but we'll go over how to make it. This is actually one slope wall, and to make you know, a couple next to it, I would just literally have to create one, and then I would just copy it over by whatever spacing it is, and now I create my 2 units, or however many wide units it's going to be. Make sense? Hopefully it does. Okay, so we're going to dive into creating a slope wall. So the first thing you want to do, which I typically like to do, is I like to create a reference plane. So this reference plane is going to define your face of system. So I made this reference plane here. Again, to make a reference plane, you go to architecture, and over here there's this reference plane. I went ahead and did that, and then I created, I'll show you, you can create one. You create that, and then you can use that as your guide. So there's my reference plane. Okay. The next thing you need to do is, I'm going to go over is click on this roof, and you hit the drop down. There's a roof by footprint. You also notice there's a roof by extrusion, a roof by face. We don't use these two, but we're just going to use this roof by footprint. All right. It's going to ask you which level you want to be the lowest level of your roof. So it might default to level 2, but if you want it to be on level 1, you can change it to level 1. Yes. So once you hit that, it's going to go into this roof feature, create footprint. And I'll explain what that means in a moment, but I just kind of want to open this up so you guys can see it. Now that I'm in this, I can click on my properties here. It says basic roof. I actually want to change that to what's called slope glazing. So the slope glazing is basically the roof that's made up of, you know, glazing instead of an actual, you know, basic roof, or what they have here is steel truss insulation on metal deck. But you can actually use the slope glazing. I made a slope wall RO and a slope wall unit. So for the purpose of this, I'm going to use a slope wall unit. I'm going to create one unit. So I'm going to select that. And then I'm going to create a footprint. So what that means is I'm going to use this rectangle. I'm going to start on my reference plane that I made and just create like a little box. Let's do 5 feet by 3 feet. And then that's my footprint. So to explain this, this unit is going to be 5 feet wide, and this footprint, or the way it's going to slope, is like 3 feet. Again, I'll explain that right now. But you'll notice these little symbols here, and what that means is Revit wants to slope it. So you can see if I highlight all the lines, or if I select one line, you can see where it says defines roof slope. So that's checked. I don't want all of these to slope, because then I'd get like a weird shape. I just want one of them to be sloped. So what I can do is uncheck that, and then they go away. So right now, none of them are going to be sloped, but I need to define what that slope is going to be. So say, for example, I wanted my wall to be sloped out of the building because this is the exterior. I can use this, what's called slope arrow, and define that. So I'm going to say it's going to slope from here to here. So it's telling me that the slope of the wall is going to be this way. And before I change any properties, I'll just show you what this looks like. Okay, so I made just a boundary. I defined my slope arrow, and then I'm just going to hit the check mark. All right, so there's my sloped wall. If I go to 3D and come over here, you can see what's happening. So it's sloping away from the building. So this is the inside of the building. This is the outside. You can see it's coming out. So that's how you would make a sloped wall. So now we need to customize it to what we want to be, right? The slope, the height of it, all that stuff. So when I talk about footprint, let's go to level 1 and let's go to the elevation.
So real quick, Gabe.
Yeah.
For defining the slope, do you always have to draw that little arrow, or can you just select like one segment and say that one segment is the slope?
Yes, exactly.
Okay.
So if I go to that and I don't do this, I would actually define this as the slope, and then you can change your slope angle here. So say you had a specific angle that you wanted, like 80 degrees or whatever it is, or 89 or whatever angle you want, 85, then you would just hit a check mark, and then it would still slope it. So either way works. So depending on what you want to put in there.
Gotcha.
I personally like the slope arrow because I can control it a little easier. Yeah. But I'll show you what that looks like. So we created a view. So for those of you that want to create a view, you go to the view, elevation, and then for some reason it doesn't want to pick up the slope or a sloped wall. You just hit tab, and then it'll rotate it, and then you can click, and that'll create a new elevation for you. And now this is my elevation, and then I would just create a little section using, sorry, I'm going fast, view, section, and use the WW detail spool, and just cut a section through here. So you can see that I have my sloped wall, and these are from before, so I'm going to delete these. And this is my faces system. So you can see if I hover over my sloped wall, you can see that that's where the starting point is at the bottom. And then it slopes out. And you can see that it's going all the way to this floor line, which is the 10-foot. And I'll show you where I got that from. But let's show you an example of what we're going to do here to get this put mullions in there. So I have Santana West, and I have this mullion here, and it's sloped. The slope wall is going to be 92.17 degrees. So I'm going to use this family. So these families here with this sill track as my sill, and then I'll use the head, which is going to be this one, this head, which is this family here, so I can put them in my slope wall. So I need to first create that reference plane to be 92.17, whatever it was. I typically create that as a reference again. So from my intersection of my level, I can draw this here, and I can put that there, and then I can just draw a dimension. Angular dimension. And then I can change this to 92.17. So that's going to be my slope of the wall. Okay. So that's my guide that I want to use. And based on this detail, I need to put this sill in. And like I mentioned before, the sill track is going to be separate from the sill member. So we need to put this in first, and then we can adjust for the sill track. So I want to make sure that I know the size of the sill because I have to push the wall up by that amount. So looking at this, the size of this sill member is I got from the family is 3.5 because it goes to a little bit below the sill member, 7/16, I believe, or I forget what the dimension was for this one. So it's 3.5, and then the rest it would be 1 3/4. I'll show you what I mean by that. So to load in the families that I need, I typically would go to WW modeling, and then I would go to load mullions, and then this would actually bring in the ones I want, so you can select them. I already did that just to save some time. You can see I have them here. So to put the mullions on the slope, you can actually just drag them on and then place them, or you can go to, define it in the type. So I'll show you that too. So let's actually get this wall to be on the right slope. Yeah, let's do that. Okay, so what we need to do is move this up by 1 3/4, 1.75 inches. You can put the little base offset there, and it moves the wall up. But it moves it up straight up, so we just got to remember to move it over to follow this slope. So if I click on this, for some reason it moves it straight up and not to the slope that I want. What happened? Where is he? We gotta put a mullion in there and it'll do it. Texture, mullion. And then let me go to that one. Maybe it's that one. There you go. You can see that my mullion is in there. And I want this point to be on that line. There we go. So now I can use that point and create my footprint. So what I meant by footprint is, like, if I have my base point here, how far over out of the building is the top of my wall gonna go to? So for example, if I create a line, so there's a lot of layout to this. So if I create a line straight up, and then I want it to be to this level here, click there, and then I come over. So this amount here is my footprint that I need to use when I lay it out. So for example, I would go back to my floor plan, and I would click on my footprint, and I would change this. Instead of 3 feet like I did before, I would change that to the dimensions that I calculated from the section, hit the check mark, and now if I go to my, oh, did I do it wrong? Oh no, sorry. That's gonna be my footprint. And then because I moved it up, I actually have to move the head down because I'll show you some of the properties now that are defined based on the slope. So you can see that it's starting at 0, and then it's going to 10 feet. I actually moved it up by 1 3/4, so I just got to move this down. Oops. 9, 10 1/4. That's going to shift my wall down. So now it's right on that 10-foot mark. Okay, makes sense so far? Hopefully. Okay, so now that I have my slope, I can start putting on the mullions. So like I mentioned, you can either define them in the type, or you can just go to architecture, mullion, and then click on which mullion you want. So this one's going to be the 3165, and then put it there. And then I would just go to put the jams in there. So if they're jams or verticals, depending on what it is, right? I just loaded jams in here. So this is the left side, and then this is the right side. So that would be my slope, and then I put my mullions in there. And let's take a look at the section. So now you can see I have that head. sill, and then to make a section, to look at it straight down, you kind of have to be in, to look at the plan view, you need to be in a section view and cut it at that angle. So what I mean by that is if you go to view, section, you can't cut it straight across, because then you won't see anything. It needs to follow the wall. So if you see where it says perpendicular, and it's at 177.83, then you know you're going to look down, and then you'll actually see the mullions there. The window is really small. You just got to extend it over. So those are your mullions for your jambs. They're verticals. You would switch those to verticals again. And then say you wanted a horizontal like this one. What you would do is you would just go to architecture, curtain grid, then you would put a curtain grid in there. I just placed one, arbitrarily, but to get it to exactly where you need to, again, the section is going to be your best bet. So you go to your section. You can see that I have my curtain grid here for my horizontal. And then let me actually put a horizontal in there. So again, architecture mullion, go to a horizontal, and then I can either place it here. Oops, I think I put the wrong one in there. This one? Yeah. So now I have my horizontal there. And one key thing to note is all of these dimensions, they're not really the true one that the takeoff program is looking at. All the takeoff properties are from the level. So if I click on this grid, you can see it's giving me a dimension to the bottom of this wall. So if I ran the takeoff browser and I refresh this, it's gonna actually read the model and see what height it is from the floor line. So you can see the one I did previously is right at the 4-foot mark, but the one that I just created, let's see where that's at. So now I can see I have one at 4 foot and then one at 5 foot 7/8. So I want to make sure that it's at 4 foot. So what you can do is again use a reference plane, create a reference plane here, and then make sure this is at 4 feet. And you want to make sure that your grid at this point here, which is the datum point, is at that 4-foot mark. So you can move this down and make sure that hits that 4 foot. So you can see that if I click on the curtain grid again, it gives me like 3 foot 10 and something. But if I rerun the takeoff browser, you can see now it's at 4 foot. So I was looking at it 4 foot from the floor level. And then the last thing would be to put in the glass. So the glass on this is actually a manual process right now. We don't have the ability to run like GG 2.0 on it yet. But what we'd have to do is we'd have to change these to the WW glass standard family, and we would input all the bytes and all the other parameters like GG 2.0 would do for us on a regular elevation. We'd have to do it for this manually. So what I mean by that is, I go back to my section on this one, you can see that it's a little off. All the parameters are not set correctly. So I'd have to go in and adjust those manually. But the good thing is if you do it once, you have the ability to copy it, or use what's called the match properties. So if I did this one and I hit MA, I get the little paintbrush. Then I can tab into that one and then select this one, and then it takes in all the properties of that one. You do that and do this one. And now these two are the exact same. So I'm not going to go through how to modify all the glass data. Eventually, hopefully, we can get the GG 2.0 working on slope walls. But yeah, then you put the glass, and that would kind of be the last thing you would need for the slope wall. Now, if I go in there, that's for the unit itself. And say, for example, I needed to move this head down. I would just modify the settings. So if I go to Edit Footprint, go back to my floor plan, click on this slope arrow, and then say I wanted to, move it down. And according to the PDF, there's a 1 7/8 cock joint. So I can, move it down by that much. Equals -1 7/8. Now if I go back to the elevation section, you see it move down. But the thing with this is you just have to make sure you're adjusting for that new footprint. Because before the footprint would come all the way up to here, but you're losing a little bit of footprint, so you'd have to find that new distance out. We're going to annotate. So this one would be 1 7/8. What? Did I make a mistake? I think I made a mistake on the footprint. Okay, footprint. Did I make a mistake? 3. Yes, and then let's see if I did it right this time. Yeah, there you go. So now you would just account for this distance between here and this point. Whatever this new dimension is, you would just put that in. Right there. The board 105 256, and then that will give us it should have gave us the right one. Maybe I did something wrong. But yeah, so then that would be your unit. And then to get the cock joint and sill track, you would make another one. And you would get it to the right opening size. And then you would just put your sill track here and then your cock joint up there. So it's basically 2 walls on top of each other. But there'd be nothing in the middle, just some cock joints at the top and the sides, and then your sill track at the bottom. And then once you have one, like I said, you can just copy it over, copy it up, and then just change out your mullions if they're stack joints, or if they, if the mullions change, or you adjust your heights. I know I went through that fast. There's a lot of steps, but the one thing that I wanted to mention again is, depending on the way the wall sloped, you would have to select the slope exterior faces down or not. So if it sloped into the building, again, you would need new mullions, because for whatever reason, Revit thinks, this is the exterior now, this is the interior. So, we just have to have Team Esley to swap the mullion, flip them so that they get shown correctly. All right. Is there any questions or anything that you guys wanted to see other than that? That's pretty complicated.
When it comes to dimensioning this in section and elevation, is there anything different than a normal curtain wall?
Let's see. So how would you typically dimension it? Would you dimension it to that datum point right there?
Yeah, and well, the one thing I was kind of noticing is I haven't done a sloped wall in a while since CAD days, but when I did, like the family was such that it was still kind of came in perpendicular to the ground, or I mean the horizontal.
Yeah, so like when I used to draw them in CAD, I usually have kind of two sets of dimensions. One, I'd have plumb dimensions that would go vertically from like floor level up, but then I would also have aligned dimensions to go with the slope.
Gotcha. So let me show. This is what you're saying. Let's just make that a quarter. So you would do like here to where that point would be, right? The dimension point. So it'd be like that 4 foot mark. And then you would do like here to, oh, not there. Would you do like something like that?
Yeah. So
Like
it just looks like
horizontals.
we just need reference planes then to get all the
Yeah, I would probably say the reference plane just in case, you know, something happens. But yeah, it has to be at that where the face of system and that that line cross or that point is.
Okay.
That would be your dimension.
But Gabe, essentially for the dimensions, in this case, you're making it like it was just a unit that was tilted. But if it wasn't tilted, you know, it's straight, yes, right? But typically, or I think I have seen also like the mullions being sloped. So that just give you one reference point, right? Like top of floor, top of horizontal, and your horizontal will be straight. Or do.
Oh, so like you're saying it goes straight across?
Yeah. Because like
yeah,
in this example.
Go ahead.
Yeah, so like in this case, in this sample, it's just really it's just a unit, you know, that has been tilted, and you're I don't know, the takeoff team just makes it is making it straight, and you know the tilt it gets put on as the unit is installed. Yeah, right. But so your dimensions really are straight dimensions.
Yeah. Yeah, let me see. I'll put another grid in here. So do like that. Like top horizontal, top horizontal. Yeah. You can do that too. Yeah, so like I said, this is kind of like our workaround. You know, when we first started Revit using 2016, this was kind of the only way we found to work that we can actually do a takeoff on the slope walls. We've done it on, we've done this way on 213 East Grand, Natural Resources, Long Beach. So it works. It's just a lot to it. And like I mentioned, you know, hopefully, you know, we start getting projects in Revit 2021 where we can actually take advantage of that slope wall feature. So we don't have to do all this. But yeah, any other questions or anything you guys want to see? No?
Would you put the
No?
sill in the same way as you would normally a plumb curtain wall?
The sill track?
Sill, yeah, sill runner, sorry.
Yeah, no, this one, we'd have to create another wall. So there'd be another wall that goes from the floor level to, you know, the top of it. And that wall will just have the mullions. It would have a cock joint and it would have the sill track. And then in between, we just have an empty glass unit. And that's just to show, you know, the cock joint and then to get that sill track in there. But because we can't nest the roofs into roofs or have a wall that's sloped, that's kind of our workaround that we've came up with. Another feature that I kind of messed around with, I'm not sure if it'll help anybody, but there is another feature called roof by face. So if we had a roof that was kind of this weird shape, so let me go ahead and create a mass and place mass. I'm just going to create a little box. And I'm going to make a solid. So say, for example, our wall did something like this. Come on. So it was like this, and then this was like sloping out like this. And, you know, did something crazy or whatever. And we did that. If we had something like this, we could use that roof by face, and then we can select this face and then create the roof. And for some reason it moves it to the bottom, the top, but it should be at the bottom. Then we can create a roof like that. And the good thing about this is if this gets adjusted for whatever reason, it gets smaller and it gets moved down or whatever it is. Let's see if I just messed it up or not. Update to face. Yeah, I can't make that roof. I think that last thing I did was messed it up. It just got smaller. And I update to face. We can do something like that and then just apply our mullions. But again, we can actually build something like this, but it's just, I thought I'd throw it out there because I know like Santana West has a pretty crazy, like 2 sloped walls coming together that are skewed. So maybe we can try something out like this. But yeah, I mean, that's another feature. But again, if you guys want to play around with it, you guys have any questions while you're messing around with it, let me know. And again, there's specific mullions that will work on this sloped wall, not the regular mullions. Oh, and that reminds me of one thing. With these mullions, with our regular curtain walls, we have these offset values. So if I go to edit type, I have an offset value of -2¼ That's from backup pocket to the face of, or your dimension point, like face the system. With the walls or the mullions on slope wall, that's actually 0. So the family team will actually create the wall, create the mullion to be at that dimension point by default. So they don't actually have an offset parameter because it kind of throws everything off if you have that offset parameter in there. All right, yeah, another thing to look out for. So whenever you use that load mullions, you change that to 0 before you load them in. Okay. Good.
Good. Thanks, Gabe.
All right, that's all I have. Let me know if you have any questions, and stay safe, stay cool.
Thanks.
All right.
See you
Thanks,
guys.
everyone.
Bye. Thank you.
All right, see you guys.
Bye.